Hello friends, in this session we are discussing about two theorems.
In composite function,
First theorem is if f defined from a to b and g defined from b to c and both f and g are 1, 1,
then
show that the composite function g of f from a to c also 1, 1. So first we will take let x1 and x2 belongs to a
such that
g of f is equals to x2. And as we have to prove 1, 1, that means we have to prove this implies that x1 is equal to x2. So let's start. As it is given that g is 1, 1. Since g is 1, 1, that means gy1 is equals to gy1 is equal to gy2 implies that y1 is equals to y2. So here g, so this implies that fx1 is equals to fx2 as well. This is our y1 and this is y2. Now as f, function f is also 1, 1, so since f is 1, 1, so fx1 is equals to fx2 implies x1 is equals to x2. So you can here write x1 is equals to x2. So g of x1 is equal to g of x2, implies that x1 is equal to x2. Therefore, g of f is 1, 1. Next theorem will prove the function f defined from a to b, function g defined from b to c, and g of f from a to c. If f and g are on 2, then we have to prove that g of f, that is a to c, is also on 2. So we are taking here, we are taking an element z of the domain on the set C, and as g is an onto function, so every element of g for all z, there exists y belongs to set B such that if y is equals to z. Again, g also onto, since of f is also onto, so for all y belongs to B, there exists preimage x belongs to A, such that fx is equals to y. So we obtain g of fx is equal to fx is equals to y, so gy is z. So this implies g of f is an onto function. Now we are discussing some properties of composite function. Properties of composite function. Here the composite function is associative. That means if we take three functions, f defined from a to b, g defined from set b to c, and h defined from c to d, and then h of g of f is equals to h of g over f, and also f plus g is equals to f of h plus g of f, something distributive. And we will give an example of this one later on. And then property 3, that is if f mapped on a to b and g mapped on b to c are two functions, then f and g are both 1, 1, then g of f is also 1, 1. Just now given it. We proved this one. And next property, if f and g are both on 2, then g of is also, that also we have to prove. We proved these two. One thing, the converse may not be true. That is, if g of is on 2, then f and g are always on 2. It is not necessarily true. And if g of is on 1, 1, then f and g are not necessarily 1, 1. Okay, thank you.
For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.